Today we're going to talk about infinite geometric series. So up until now we've talked just about arithmetic series. Today we're switching over to geometric series. And in order to do that, we need to review geometric sequences, which we learned about at the beginning of the year. So this is a review. The geometric sequence is a sequence in which each term is equal to the previous term multiplied by a constant. You should remember our recursive formula. Remember the recursive formula simply tells the pattern of the sequence. U sub n equals the common ratio times the previous term u sub n minus 1. So what that's saying is, to get any term u sub n, take the term before it and multiply it by the common ratio. Our explicit formulas, we know, are used to find an explicit term, or a specific term. And we have two of these. The first one is u sub n equals u sub 1 times r raised to the n minus 1 power. But if we're not using u sub 1, the first term, we're using the initial term, u sub 0, then we use the second explicit formula. U sub n equals u sub 0 times r raised to the n power. Alright, we're going to introduce geometric series with this example. Jake baked a pie and promptly ate 1/2 of it. Determined to make the pie last, he then decided to eat only 1/2 of the pie that remained each day. In part A, it says, record the amount of pie eaten each day for the first 7 days. So since Jake ate half of the amount of pie left each day, on the first day he ate half the pie, the second day he ate 1/4 of the pie, on the third day he ate 1/8 of the pie, the next day at 1/16, then 1/32, then 1/64, then 1/28, right? 1/128. So the amount of pie that Jake is eating each day is decreasing significantly. Part B, for each of the 7 days, record the total amount of pie eaten since it was baked. So to answer part B, we had to find S sub 1 to get 1/2, S sub 2, meaning add up how much pie he ate in the first 2 days to get 3/4. S sub 3, how much pie did he eat in the first 3 days. S sub 4, the sum of how much pie he ate in the first 4 days. S sub 5 would be how much pie he ate in the first 5 days. S sub 6 and S sub 7, right? And look what's happening to how much total pie Jake has eaten. Initially, he ate half the pie right off the bat. And you're probably thinking, holy cow, this guy's going to eat a lot of pie. But the series, right, the series, S sub 1 was 1/2, S sub 2 was 3/4, S sub 3 was 7/8, 15, 16, 31, 32, 63, 64, 127, 128. The series themselves are decreasing, right? They're not decreasing, they're converging. Sorry. They're converging to the number 1. Each of these numbers that you see here is getting closer and closer to the number 1, but it's never going to actually equal the number 1. So when we go on to part D, or part C, it says if Jack lives forever, then how much of this pie will he eat? Well, this series is converging to the number 1, but it will never equal the number 1. Jack will never actually eat the whole pie. So we'll say he'll eat about 1 pie. And the reason that this example is so important is because we're seeing for the first time that a geometric series can converge to a single number. And that takes us to some definitions here. The indicated sum of a geometric sequence is a geometric series. An infinite geometric series is a geometric series with infinitely many terms. A sequence of partial sums that approaches a long-run value as the number of terms increases is called a convergent series. Each one of these definitions ties back to the example of Jake eating the pie. The first one is just like asking, what was f sub 4? How much pie did Jake eat in the first 4 days combined? The second one is just like part C from the example that said, well, what if Jake lives forever? Meaning that sequence would go on forever and ever and ever, right? Okay. And the last one here, the convergent series, this is just like the answer to part C. The Jake would never actually eat the entire pie. Because even though that series goes on forever, it converges to the number 1, right? 1 pie. And so that's where these definitions sort of tie back to that example.